Until someone pulls down the bash source code and writes some C code to make their own loadable plugin, it's not going to work the way we want it. So we would need someone crazy enough to do that. All right, so today we're going to write a web server purely in bash. Okay, so like the title of this video says, that is not a lie. We're going to try to make a web server today that uses pure bash. What do I mean by pure bash? I mean no external commands. We're not just going to fork out and start Nginx and be like, oh, we wrote a bash script. It's one line. No, that doesn't count. Okay, you know, people are like, oh, I wrote this Python program that does all this machine learning, and then you look at the code. It's like from machine learning import do task, and it's like I think someone else made that code. Don't get me wrong. We're going to use code that's been made by other people, but we're going to do the bulk of the heavy lifting in bash. Okay, no external utilities, no GNU user land, no POSIX utilities. We are going to try and sit as close to the bash source code as possible by using built-ins, and we're going to see how far we can get. So yeah, let's jump in. All right, so to get started, I want to talk about some other projects that have done this because I'm not the first one to attempt this, so I figure I should mention some of the bigger projects that use this. The first one here is the bash stack. If you watch my channel, you're familiar with the bash stack. The author of this, I'm friends with her, Bad Cop. She's been on this channel a bunch. She's really cool. So the bash stack is awesome. It's written in bash. And if we go to the developer docs, we can see here, if we go to the quick start, where's the quick start guide right down here, we need bash 4.0. We need TCP server, which is an external C program, compile program, and the GNU core util. So this one's out. Really cool project, but it's using external tools, and we're going to try and stick with the built-in ones. There's this article, I did some Googling. I found this really cool article here on building a web server in bash, part 1, sockets, and right down here, netcat. So this one's out. It's relying on an external utility. We have this other article. This is just for some quick Googling. Look at this example right here. Even in this little screenshot, pipe it to netcat. So again, external utilities, cool, but still external utilities. We have this one, bash HTTPD. This one's 11 years old, so I'm not certain what it's going to be using in terms of built-ins, but look right here, bash socat, netcat. So again, external utilities. And then we have this one. This one's interesting. As you can see, there are some patches to bash, and it's a pure bash web server, and it references a specific version of bash, and there's some patches in here, and there's accept.c. We're going to save this one till the end, okay? I don't want to spoil anything, but we'll come back to this one because this one's very important. Okay, so with that out of the way, let's talk about our goals today. Our goals today is to have a single file bash script. That is a bash script in one little file that we can execute, a couple hundred lines, maybe, we'll see. I want a single file that I can execute and it will serve HTML files or any sort of files out of a directory. So I wanted to do directory listing. I wanted to be able to serve binary and text files, and I wanted to be able to listen on an arbitrary port, on an arbitrary address, and serve out an arbitrary directory. That is my goal, and my goal, again, is to not use any external utilities. I don't even want this thing forking and execing anything. I want this thing to just be in pure bash. It can fork, but I don't want it to exec a different process. So we should not be calling cat, ls, netcat, socat, none of that stuff. It should be all built into bash. So let's get started. All right, so first thing we're gonna do here, let's go into my dev directory. This is where I do my development work, and we will do a makedir bash web server. All right, let's go in there, and let's vim bash web server. And this will be our script. This is where the web server will live. Okay, so now we have a simple file called bash web server here. Let's go ahead and make this executable. We can go ahead and run that file, and look at that, nothing happens. That's great. At the end of this, we should have, hopefully, an HTTP server that runs out of this single one bash file. So to get started, we need to talk about how are we going to listen on a socket? Because this might not be something you're used to in bash. In fact, bash doesn't have a built-in way to listen to a socket, but that's where our first asterisk comes in, okay? This is our first little gotcha. Bash actually does have a way of listening in a socket, but it is a loadable built-in. So let me explain what I'm talking about. We can pull up the bash source code here. So we have the born again shell right here, hit source code. We can browse the Git repository, and here is the source code to bash. We can hit the tree right here, and now we can see all the stuff that comes with bash once this page loads. If you're not comfortable with this interface, there is an unofficial mirror on GitHub. You can go ahead and load this up. bminer is the username, bash here. So sometimes I go check this out just because it's pretty easy to browse. So we'll use this interface instead. We have examples here. Go into the examples, go into the loadables, and now there are a bunch of commands here that are built into bash but need to be loaded at runtime. So these may or may not be compiled with your system. There's a whole bunch of stuff here. As you can see, like hello is one of them, dir name, cut. These are things that are normally external utilities but can be built into bash. So let's use a simple example here. So we have uname right here. If we go back over to the terminal, we can take a look at uname, type uname. And as you can see, it's user bin uname. If we run it, it prints dar when I'm on my Mac. If we enable uname, that will enable the built-in that was from that source code on that website. So if we do type on uname, we can see it's now a shell built in, and we run it, and it runs. So there's no fork and execing here. This was compiled, and it was pulled in at runtime. So we have access to these plugins that you may or may not know about with Bash. So let's go back here. Why is this important? Well, there's one really important thing we're going to use here: accept. Accept.c. Listen for and accept a remote network connection on a given port. So accept is going to be the thing that allows us to open our socket and listen for incoming requests. We're still gonna have to do a lot of parsing of HTTP on our own, but accept will at least allow us to listen on a socket. This is similar to like what those netcat examples were doing. So let's go back to our terminal. And now that we know about accept, we can enable accept, and we can get a help message on accept. So here is how the accept built-in works. We can see that it optionally takes -b for address. This is the address as the IP address to bind to. Otherwise, it's in-add or any. This means it's listening on all interfaces by default. We could override this and give it a specific interface. We could say 127.0.0.1 to only listen on localhost. We have an optional timeout argument here. So wait timeout before connection, blah, 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 blah. -v, this one's important. Store the numeric file descriptor of the connected socket into var name. The default var name is accept fd. So if we don't pass this in, this variable will be set, and this will have the file descriptor that is currently listening. So the last thing we have here is -r. This one's optional. Store the IP address of the remote host into the shell variable rhost in dotted decimal notation. So this is really cool. As we start getting different connections from different things, we can see what the IP address actually is. So let's go ahead and do a quick example of this. So if we did accept, we could say -v, let's just do fd, that's the name of the variable, remember, and -r IP, and the last thing it takes is a port to listen on. So let's listen on port 8080. So if this works, we get nothing. Why do we get nothing? Because it's actually listening. It's hanging. It's waiting for us to connect to it. So let's go ahead and open up another terminal. So as you can see, this is still running in our first terminal over here. I'm going to pan over to the other terminal, and we're going to connect to that socket. Netcat, we're going to connect to localhost 8080, and we're going to say something. Let's say, hello. And then we will close the connection with Control D. And then we go over here, and you can see accept has returned. So we have this variable now. We can echo fd and we can echo IP. So the file descriptor is 4, and the IP address that it came from is 127.0.0.1. So what can we do with that file descriptor? There's another read built into Bash called read. Read-u. This takes the file descriptor, and then we can read that into a line. So we'll run this, and there we go. Now if we echo line, it got hello. That was the data we passed over here. So we go over here and we can see that's hello. It's still running. Notice that we tried to end it over here, but it's still running. How do we close it? Well, that was file descriptor 4. We can do this. We can give it in this notation, curly braces around it, greater than, ampersand, hyphen. This will close the file descriptor. This is effectively calling close on the FD. We run this. We go back over to netcat, and we can see that it closed. We closed the connection. So that is how the accept built-in works. You get a one-shot of a port and address. So let's actually put this in a script. So we have our Bash web server. Let's go in here. Let's enable accept, and then we can break out here. Already, we want to put some error checking. So let's go ahead and do my favorite thing. We're going to make a fatal function. So we can say this. Let's print all the arguments that the user gave us. Let's write that to standard error, and then let's exit 1. Now we have this function called fatal, so we can just say like fatal failed to load accept. There we go. So now we know either this works or we got a fatal message. So if we go ahead and run that again, we should get nothing. That's good. That means the accept built-in was loaded. Now we can go down here and we can actually run the accept thing. So let's go ahead and make some variables up here. Let's say our port is 8080. Our address is 0.0.0.0. This is every single IP address possible. So now we call accept, we can do this. We can do -b address port here, and then we can say echo listening on http://address port. Now it'll print this and it will run here. So now when this returns, we can read in from that file descriptor that we got. So u is the FD, read that into line, echo got data line. There we go. So let's go ahead and run this little web server that we got. Listening on HTTP 0.0.0:8080. So let's go back over here. Let's actually curl it. Curl localhost 8080. And what's going to happen? Well, we got an error. What happened over here? Look at this. This got the first line of data, but that's it. It only got one line of data. Turns out there was more data to get there, and we can get that data by using a loop. So there's a couple ways we can do this. I like to put this in a while body right here. So now we can say while this read call was successful, UFD line. Also, I'm going to throw in a -r. This will stop it from mangling backslash characters. We can say got data line. And then when we get down here, we're done reading the data. So we can be good and we can close that file descriptor, close the client. So let's go ahead. Let's rerun this. Go over to this terminal and curl it. And let's see what happens. It's hanging. Something's going on. So what's happening here? It's trying to read again. That's what's happening. Even though it seems like we should be done processing data, that socket that has open, it's technically bidirectional. It can read and write to it. So it's still trying to read. It turns out the onus is going to be on us to actually stop reading at a certain point. But look at this. We got this nice little data here. Here is what an HTTP request looks like. So what can we do? We can check, let's take a look actually right here. We can check to see if we got an empty line. This is part of the HTTP spec line. It has this line at the top, and then it has headers, which is key colon value, key colon value, key colon value until there's a blank line. Once there's a blank line, then either the body comes below it or the request is over. So we can match on that blank line. So we can say if line equals empty string, or we could do -z line, meaning is empty. Then we can actually match on it. So if this is empty, then we will break out of this loop. We're done processing headers. There we go. So we can break out of the loop. And then when we get down here, we'll close it. So what's going to happen when we run this? Something really interesting is going to happen. We don't actually break out. Why don't we break out? That's because in the HTTP spec, we don't just get new line separated data. We get something called curlifs, CRLF, carriage return line feeds. So this is not empty. It's actually equal to one thing, which is a carriage return. It's an invisible character. We can't see it, but we can test for it. So we could do something like this. That's a way to check for it. So we're saying this is a special character in bash, and the special character is \r. So it won't be empty. It will just have the \r gone from it. Now here's the nice thing. Every single line is going to end with a \r, and we're going to not care about that. So what we can do is we can filter it right here. We can say line equals line, and then %, meaning start from the right, and delete the first occurrence of that we see. We have to put a $sign here, so it's a special character, and that should filter it out for us. So then we can go back to this. If this line is empty, we'll do this, and this should work now. Let's go ahead and run that. Let's go over to this terminal, run this, and we got an empty reply from server. We go over here, and it's done. Look at that. That's beautiful. We were able to accept the data from curl. We just didn't write anything back. We're not being very good. So why don't we be good? Why don't we write something back? If we are here, we should reply to the caller. So how do we reply to it? Well, we have to write to that file descriptor. How do we write to the file descriptor? There's a couple ways. One of the easiest ways is just to use printf, and then we can just write to that file descriptor, no different than how we would in any other bash program. So what are we going to write back to the program? Well, we have to signal that there was a success. Let's just make it look like every single request was successful. We're just not going to return any data. How do we do that? Well, the first thing we have to do is we have to return the version. So HTTP 1.1, and now we're going to say 200 OK. 200, that's our response code. We're saying everything was okay. Now we have to do the curl ifs. Carriage return, new line. There we go. And we have to write that to the FD. This is a little bit weird syntax. We're saying greater than, meaning to write to, the ampersand meaning an FD, and then we have to put the actual variable with the file descriptor in there. I put it in quotes. It should just be a number, so it shouldn't matter, but this is the proper syntax for that. So we wrote that. That's really great. We could also say something like content type, I don't know, whatever we want, text/HTML, text/plain. There's a whole bunch of different content types. And then we can do this, and then we can printf just a blank RN, and this will just be signifying that the headers are over and we're onto the body. And then we can printf something like hello, new line, and then write that to the file descriptor. So what's going to happen now? Let's go ahead and run this, come over here, run that curl again, and we got hello. Look how amazing that is. Isn't that beautiful? We ran our little script over here, and this got back hello. And it wasn't just a raw socket, it got it in HTML formatted data. How incredible is that? We are making a web server in pure bash. It's a lot of work to get here, but the payoff is going to be huge once we have something a little more substantial working, but this is pretty cool. So where do we go next? We have the accept built-in working. We have the reading and writing of basic data, which is awesome. We're writing a basic 200 request. Now, we're not checking anything. We're just writing 200. We're just saying, hey, you gave me some data? Cool. Awesome. Here's a 200. So what can we do next? Well, we could serve a static file. So we're just putting hello here. We don't have to do that. We could put something like this. We could say like, I don't know, file.text. And we'll just say, hello world. This is a static file. Hi. There we go. So now if we go back to our bash web server, instead of doing this printf, we could just cat file.text. Now hold on, I know you might be thinking, wait, isn't cat an external utility? The answer is yes, it is. But we're going to leave it in for now, and then we're going to come fix this later, okay? This is just to get us off the ground. This is just to have something working really quickly. So we'll run our little web server, we'll go over here, we'll curl it, and we got the contents of the file. How amazing is that? If you're wondering what's happening here, because we're using HTTP 1.1, we don't need to specify a content length. It will assume that the content length is chunked encoding, so it just keeps reading data until the socket closes, and that's why we manually close the socket down here. So curl just keeps reading data until there's no more to read. So that's how that works. Super simple, super basic, but hey, it gets the job done. So the next thing we want to handle here is we are just statically giving it file.text every time. We don't want that to happen. We want the user to be able to request it, right? I want to be able to say file.text here and have it give it to me. Now, spoiler alert, it will work, but that's just because it's always going to give us file.text. If we put, foo.text, it failed because the web server closed. Let's go ahead and reopen that. We'll deal with that later, don't worry. If we do this, we get the same file. So we need to be able to parse this part out of the URL. And in order to do that, we have to actually start parsing the incoming data. We can't just blindly ignore it like it's been doing. So we're going to write an HTTP parser. You ready? It's going to be a ton of fun. Let's go. So to iterate on this quickly, I'm going to make a new script that is just for handling parsing the request. This way we can iterate on it real quickly and we move it into our script when we're done. So let's go ahead and make parse request. Before we do that, I'm going to copy some of this stuff into my clipboard, okay? I'll show you why in a second. User bin env bash. Let's go ahead and save that. Pull it up here. Now we can do something like this. We could say s equals, and then we can put all this data into here. Of course, we got the colons and stuff. That's annoying. So let's go ahead and save this. And we're doing this so we can parse this back in this program and make sure that we can parse something that looks like this. So we have a string that has this data in it. We need to be able to parse this data. So let's go ahead and make a function called parse request. And this will take this data over standard in, and we'll call it like this. So basically, this is the stuff we care about right here. This function is what we're going to care about. This is what we're going to copy over into our code once it's working. But to allow us to test on it, we have this string that has this hard-coded data in it right here. And then we have this call. So this function will get standard in of that string. I'll show you what I mean by that. While read -r line, do, done, echo, processing line. There you go. So now if we run parse request, it will process each one of those lines individually, and we don't need to worry about it, which is pretty cool. So what we need to do here first is we can say line equals, it's what we had before, line equals line percent \r. Let's get rid of that carriage return. In this test data, there is no carriage return, but when we come to the actual parsing of a real request, there is going to be that data there. So we need to think about what we want this function to look like, because there's a lot of data we get out of request. What do we get out of request? We get the verb, the method. So like if the user gave us a get or a head or a delete or a post, we get the path. That's the thing in the middle. So that's like a slash or a slash file.txt. And we get the version. So right here, we have the verb, the path, and the version. Now we can do some we can check for validity here because we know the version should be HTTP 1.1. We know what the method is going to be get if we're only going to support that. But how can we return that? I'm going to opt for returning a how do I say this? An associative array. So we're going to return a variable that we know of. I'll explain as we go on. Let's declare a global array, G for global, capital A for associative array, called rec_info. This is the request information. This is information about the request metadata effectively. This will have the method, the version, the path, things like that. And then we will have request headers. This will be a key value store of every header we encounter. This way, when a person calls parse request and they get down here and it was successful, they can check something like, if rec_info method equal get, then you can do code like that. That will be how this works. So let's go here and let's start writing a parser. How do we write a parser? Well, we have two different things we have to look for. We have a couple different, we're going to think of this like a state machine. We have a couple different states we can be in. We can be processing the status line. This is the first line. We could be processing headers, any number of headers, and then we can be processing an optional body at the bottom. I'm not going to worry about parsing a body. That's outside the scope of this video. So let's just worry about the status line and the header. So the first thing we can do is we can make our state. Let's say we are in state status, means we are processing the status line. We know we're processing the status line because it's first. It's always going to show up first. Let's do a local line here because the line variable declared here will technically bleed into the outside scope. So let's go ahead and declare it local up here. And now we can check what mode our parser is in. So our parser currently is going to be in one of two modes, going to be in status or header mode. And we can check that with this. So if we're in status mode, then parse the status line. And if we are in, this parentheses bad. And if we are in headers mode, then parse the headers. And then we can check if we're in the body mode. This would be the final part of the request that we're not going to support. Fatal body parsing not supported. We shouldn't get here, but this is just to cover all our bases. Close that case statement, close the done here. Awesome, beautiful. So what do we do when we're in the status? We have three possible things. We have this, and we have this. So we just need to break them on spaces. This is super easy. We can use the read command for this. Local method, path, and version. Those are what each three of those are. So I'll just put an example here. Get foo.text HTTP 1.1. So the method is get, the path is foo.text, and the version is HTTP 1.1. We can do a little read here. We can say read -r so we don't mangle backslashes, method, path, version, and then we read in from the line. And that's it. Really, that's it. That's all we need. Now we just need to store this technically. So I shouldn't say that's it. We have to store this. So let's set the method of rec_info to method. Let's duplicate that 3 times. Path and version. So path, version, and we're done. So now that we got down here, our state is now in headers. That means the next time this loop runs, we'll be parsing headers. So what do we do when we're parsing headers? Well, we have a key value store, right? So we need a key and a value, and they are colon separated. So we need to read everything to the left of the first colon and then everything to the right, even if there are other colons there. So we can say local, oh, we already have local key value. Let's do read -r key value, and we'll read that in from a line. Now this will parse it based on the IFS. So we have to set the IFS here to a colon. So now we are breaking colon separated values. So we have key and then value, and because there's nothing here, everything to the right of the first colon will get stored in value. And this is good. This is what we want. A couple things to keep in mind here. Headers in HTTP are case insensitive. So I'm going to opt to just lowercase the header name, and we can do it with this notation. So the key, the header name, I'm just lowercasing it. That way we can get around that problem. So we're going to overwrite headers if they have different casing. The value can have some spaces on the right or left of it. So I'm going to trim it effectively. I'm just going to trim it from the left because technically it could be like, key colon space value. I'm going to trim it so we're just left with this part of it. And the way we can do that is we can use parameter substitution or expansion, sorry. And we can say starting from the left, any space character 0 or many times, go ahead and delete it. And that's how we do that. Super easy. So now we can say rec headers key, make sure to put that $sign there, equals value. And that's it. That's awesome. Now we need to check, when are we done looking at headers? Do you remember when we're done? We're done when we hit a blank line. So we have to check for a blank line. If the line is blank, then we will break out of here. We could technically set the state to body and then go on to parse the body, but we're not worried about that. We're not going to support that yet. We'll put a to-do support body, but probably not. LOL. Yeah, you know what? XXX. this doesn't support body parsing. That's a better thing, because I don't think we're actually going to do it. I think we're just not going to support it. Simple as that. So now what can we do here? This is how we parse the request, and that should just work. So we have this parse request down here. Now we can print everything that's in our rec info, and we can print everything that's in our method. So let's go ahead and do this. Let's say rec info. We can do for key in rec info. This will loop over all the values in rec info. We don't want that. We want to loop over the key. So let's put an exclamation mark here. Value equals rec info at that key. There we go. So now we can say key value. And then we can do the exact same thing for the headers. So let's go ahead and copy that, paste that, go down here, find every place we say info, and let's change that to headers. There we go. So if we run parse requests, assuming I didn't make any mistakes in programming, look at this, processing line, processing line, processing line. If we look at our rec info, our path is foo.txt, our version is HTTP 1.1, and our method is get. That's awesome. That looks right. Our headers are accept this, our host is localhost this, and our user agent is curl. Well, hey, this looks pretty fantastic. I'd say we did a really good job here. That's amazing. Are there safety concerns with this? Absolutely. We don't check to make sure they don't give us a flood of headers or very large headers. There's so many areas for denial of service here, but you know what? This is just an educational video, okay? You shouldn't be running this bash web server in production. So now that we can parse a request, we're going to go ahead and take that logic and we're going to put it into our web server. So let's vim parse request, vim our bash web server. We could leave parse request in its own file and then source it in the web server, but for the sake of this video, I want everything in one file. I want a person to be able to download this one single file and run a full-fledged HTTP server out of it. That's my goal with this. So let's go ahead and copy all that code. Let's go here and paste this code like good programmers, and now we have a nice little parse request function. So if we go down here, this is where our actual code is. This is a little bit dirty. I'm going to clean this up. I'm going to clean this up by making a main method and putting everything here in the main method, and then I'm going to call the main method here. So the main method will get called with all the arguments that the user gave it, and then we're just going to run stuff in here. Nothing really changed, just a way of cleaning up the code a little bit. If we're going to be good, we should probably clean up some of the variables we use here too. So this declares variable FD and IP. We should declare those local. This declares the variable line. We should declare that as local. And then down here, well, we don't declare any other variables, so we're good to go. So if this all works, we should have that function parse HTTP request, which does nothing. Let's just make sure that I copied everything over to main in the same way. That looks good. That looks awesome. So now that we can parse a request, let's go ahead and parse it. So here is where we read all of the data from the request. We don't care about that. Let's go ahead and get rid of that. And let's do this. Let's do some error checking here. Failed to read socket. Let's make sure that we can actually accept a connection before we just try and parse the request. We can clean this up later. Parse request. Now, as you may recall, parse request reads from its standard in. That means that we need to give it data from the file descriptor. So again, remember it reads from FD. We need to go ahead and give it data from that. So the way we could do that is we can have it read in from this. Same syntax as before, and now parse request should read that. So if we get down here, then we should have things set for us. So let's go ahead and do some basic logging here. Nothing too special, just really simple logging so we can see the request come in. Let's go ahead and run this. Let's see what happens. Go over to curl, run that curl. That looks good. Come over here, and what do we have? We have all the processing, and then we have get, but we didn't have anything there. Did I put something wrong here? Oh, yeah, look at this, rec path. I think that should be rec info. It would help if I spelled my variables correctly. Where else do we have that line that says we're processing line. We don't really need this anymore. Let's go ahead and get rid of that line. And we just have a simple thing here that says method and path. So let's go ahead and rerun this, go over here, run that curl, go back here, and we can see get foo.txt. Hey, that's looking really good already. We have an HTTP parser in bash that's doing the right thing. How awesome is that? Since we're here, we can validate the request because there's a lot of ways the user could send us a request that isn't totally great. So let's go ahead and validate that here. We can do something like, there's a couple different things we can check here, but let's do, oh my God, it would help if I could type. Rec info version. This is just some sanity checking for our own sake. Equals HTTP 1.1 or fatal, let's say unsupported HTTP version. There we go. And we can check, what else do we have? We have the method. Let's say we only allow get methods, unsupported HTTP method. And then we can check the path. There's a couple things I like to check here. What I like to check is that it starts with a slash. So we don't use quotes there, but we check that it starts with a slash. This means the user has to give us an absolute path. Unsupported HTTP, let's just say path must be absolute. This is just some sanity checking, some light security here, not really much of security, but it just kind of makes sure that we don't expect things or don't accept things that we don't expect. So we run this and it's good. It should be valid. We are only sending valid requests to it. So if we were to do something like -x delete, which is a different method, we get an empty reply from the server, unsupported HTTP method. Hey, that's awesome. That's what we wanted. It's probably not great that we just failed the request for them, but we'll worry about that as we move forward. All right, so now that we're here, we know the path that the user wants, right? So we can go ahead and look up that file and dish it out to them because that's exactly what they want. Now, if you're thinking this could get dangerous, yes, absolutely, it can get dangerous, and we'll deal with it as it comes up. But let's go ahead and take the very naive approach of doing this. So how are we going to do this? We know what file the user wants, so we should just give them that file. We can do a little bit of checking here. Let's do a little bit of checking. We're going to do things in not the best order, okay? We're going to do something that is very not Unix-like, but we are going to stat before we open. It's not great. There's a race condition. We're going to clean up this code as we go along, but I'll show you just a quick little example because, again, this web server is just supposed to be educational. It's not supposed to be something you run in production. All right, so if we are here, the user wants a path. Let's go ahead and make up an example path. Let's say they want file.txt. Well, we don't want to give them file at a slash like this. We don't want to go to the root of the file system, so we want to trim off that slash. How do we do this? This is really easy. We could do local path equals recinfo path, so we can store the actual path that they wanted here, and then we can chop off the first character of it. How do we do that? Just do a substring indexed at 1. So this just creates a substring starting at the first character, so 1 character past the beginning, and now we should be left with file.txt, if that makes sense. I'll keep these examples here. Yeah, we'll put comments like this so we can kind of see the intent of this line. So now we should be left with file.txt. So if we're here, what we can do is we can say if that file exists, so this stats the file, this checks to see if the file's there. If the file's there, then we want to return a 200. We'll return text/plain. We'll worry about this later. And then we want to actually cat that path. If it doesn't exist, then we want to do something a little bit different. We want to give them a 404 not found. Don't forget that we have to put this here to let them know that, hey, the connection's done. So we'll check to see if that file exists, and then we'll give them a 404 if it doesn't, or we'll give them a 200 with the content of the file if it does. There's some hard coding going on here of the content types. We'll worry about that in a sec. Let's go ahead and run this over here. Let's go over here, and let's run, what is it, file.txt. Hello world, this is a static file. Hey, that looks awesome. Let's go ahead and rerun that server. Let's run foo.txt. We didn't get anything back. Did we get a 404? I wasn't looking at the header, so I don't actually know. Before we continue, I'm going to do something that's been annoying me here. As you can see, we one-shot the request. We handle one request, and then we start over again. That's kind of lame. I don't love that. So what we're going to do is we're going to put all of this logic to process a request in a function, and then we're going to call it here. So I'll show you what that looks like. Process request, and then this will read in from the FD. Actually, we're going to need the FD. Nope, this will just get the FD as a number, deciding as we go along. So we'll have a function called process request that will take the FD as an argument. So local FD equals $1. And then everything that happens here will happen in that function. So what this allows our code to look like is we enable accept, we print that we're listening, we accept a single connection, and then we process it, right? So now we can just while true do, and then run this in a loop. So this web server will just continue to accept new connections, and every new connection will go into the process request. So we can just leave it running. So I go over here, I curl foo.txt, it fails. I curl foo.txt, it fails. I curl file.txt, it works. We go over here and we can see that we got 3 requests. Hey, that's pretty awesome. Let's go ahead and do -I. This will also show us the headers, and we can see that we get a 404 not found for that. Whereas for file.txt, we get a 200 OK with a content type of text plain. Hey, that's working. That's awesome. So what can we do here? Well, there's a couple things we can do here. First things first, let's break it. You ready for this? Here's a simple way to break it. What if we wanted to add a query parameter? Version equals 2. Well, that failed. Why did that fail? Because it tried to look up a file with this exact name. That's not great. So how do we fix that? Well, we need to actually parse it. So we need to parse it based on the query string, which is anything to the right of the first question mark. So let's go ahead and do that here. So we've chopped off the slash. That's great. Now let's do this. This is updating the example so we can see what we have. Let's go ahead and turn this into file.txt by parsing out the query parameter and throwing it out. So let's do local query read -r path and query and read that in from path. And then here's the magic. The field separator is equal to question mark. So now we will read, this is everything to the left of the first question mark, and this will get rid of that. So we can do some debugging here. Echo trying to find file path. We can do that. That we can see it show up here. So let's go ahead and go back here. Let's run this again. And hey, it works. That's awesome. Why does it work? Because the user tried to get file.txt version 2, and then we tried to find file.txt, and it worked. It was there. That's awesome. Are there other ways to break this? Absolutely. Yes, there are. There are absolutely ways to break this. What if we went over here and we tried to get something like, could we say foo bar baz? URL rejected. Okay, so curl's going to do some nice checking on the URL to make sure it's valid. That kind of hurts us here. Long story short, the URLs are encoded. There is actually an encoding process called like URL encoding or URL decoding. You may have seen this if you're in like JavaScript or something. You have URL or encode URI and encode URI component. So if I were to say foo space bar, we will get that %20. There's something kind of magical about that. The percent is actually just the number that follows percent is the ASCII representation of the character that's there. So long story short, we need to URL decode this data because it might have some data that we don't want. So I'll make an example. Let's vim foo space bar.txt. Hello, my file name has spaces in it. There we go. So foobar.txt has spaces in it. If we go over to the bash web server and we try to curl that, how do we curl it? Localhost 8080 foobar.txt. This will yell at us. That didn't work. So we have to encode it. How do we encode it? %20, and we don't get anything back. That's because it tried to find a file with a literal %20 in there. So we have to decode the URI component. This is going to get really cool. I'm going to show you guys something awesome. Okay, so this is the Pure Bash Bible. Shout out to Dylan here, an absolute legend in his own right. This is the Pure Bash Bible. It's a collection of really cool bashisms or bash-specific code. So it uses built-ins to do some really awesome things. Something in here is the %encode string or decode a %encoded string. I want to give a shout out to this function. Look how beautifully small it is. Like, this is incredible, right? The first thing we do is we take a string as argument 1, we convert pluses into space characters, and then we do this magic here. What is this magic? We convert a % sign, because remember, % encoding, into a \\x. That means when printf sees it, it just sees a single backslash and an X, and then the %b is built into printf and bash, and it tells it to encode it like ASCII, or decode it like ASCII. So this single function will do URL decoding for us. It's not perfect, but it's really, really cool. When I say it's not perfect, what I mean is if the user's string already had \x's in it, they technically will get interpreted as hex values when they probably shouldn't, but This is good enough. We're not going for perfect here. We're going for pretty good. Again, this web server, educational, guys. Please don't run this in production. But let's use this function. I'm going to leave it exactly as written because I think it's beautiful as written. So now we can URL decode that. So where do we do that? We did, where do I have query? Here we go. So we break it based on the query parameters. Now we need to URL decode it. So let's do another example here. We have file.txt, foobar with a space, foobar with a space, foobar with a space. Oh no, this is wrong. %20. That's it. This is what the example looks like coming in. And now we're going to turn that into foobar.txt. And we'll do that by saying path equals URL decode path. That's how we do that. So let's go ahead and run this. Go over here, curl this with the %20. And hey, it works. That's awesome. We just had to URL decode it. So what's next? Can we still break this? Oh my goodness, yes we can. Curl won't let us. Curl is very nice. Curl normalizes path names before it goes to the server. But are you ready for this? You ever seen an attack like this? Look at this. So curl changed it before it got to our server. Our server didn't do anything like that. In fact, I can prove this to you by what if we just wrote it ourselves? What if we said get /// some file like Etsy password, and then HTTP 1.1, and then rn, and then we pipe that to netcat localhost 8080. Well, hey, there's my Etsy password file on my Mac. Enjoy it. There it is. That's not great. This is absolutely not great. This is called path traversal. Very, very bad. So how do we get around this? You might be thinking base name. There's a couple reasons why that's not great. First of all, it's not built into Bash, so we really can't reach for it. There is a loadable base name plugin, but we can do it ourselves. And how are we going to do it ourselves? Well, the same way we parse requests. We're going to do it by hand first, and then we're going to fix it later, okay? So let's go ahead and write our own normalize path. This is going to be our normalized path function. We can iterate on it here, and then we can pull the code into the main code base when we're done. So go ahead and do that. Save it, vim it, and here we go. Okay, so now that we're here, let's come up with some examples, all right? These are things that we want to give it and things that we want out of it. So ideally, we would have a normalized path function, and it would take a string like the one we had before. And this should return Etsy password on its own. We can come up with some other ones. I'll keep this pretty short, but let's do something like slash, a mixture of dot and dot dot and things like that. Multiple slashes. Let's just do all dots here. There we go. So at the end of that, that should just be temp. So let's just do this. This should be Etsy password. This should be temp. And then we can do something like, we'll keep this one simple. User bin dot dot lib. Yeah, that's good enough. And then this should be user lib. At the end of it, this is what we should get. So let's go ahead and define our normalized path, and let's talk about what actually goes into this. Well, the first thing let's do, what should we do? We're going to expect the path as $1, and our HTTP parser has already ensured that we only allow absolute paths, meaning they start with a slash, but we can make sure of that. Oh, I spelled normalize wrong. That's awesome. We can make sure of that here by just putting a slash here. That way we are guaranteed 100%. This is a very opinionated function now. This function will only handle absolute paths, but we're going to guarantee that this is for absolute paths. That's it, simple. So let's go ahead and break it on our separator. IFS equals slash. There we go. Now we can do read-r-a for array, and we can read the parts out of it. So let's do a local parts here. Now we can read the parts out of it. This will break it on slashes, and we can do this. I'll show an example of this. For part in parts, do echo part. Kind of ugly, but this is just to get the point across. Let's go ahead. Let's comment this one out and comment this one out, so we only are dealing with one at a time. So if we run normalize path, we can see this is what we're processing. We're processing a blank line, we're processing dot dot, we're processing dot 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 dot, dot Etsy password. That's what we're processing one by one in our loop. The beauty of this is that we can do a simple case statement. So we can check the part. If it is empty, meaning this was a slash next to a slash and there is nothing here, we can ignore it. So we'll say, like, I don't know, ignore empty directories, multiple slash. If it is a single dot, we don't need to do anything. We can ignore the current directory because dot is your current directory. If it's dot dot, we need to pop off the last thing that we saw, which means we need to store the things that we see. So let's worry about that in a second, okay? Let's just put a to-do here. If it's anything else, then we need to store this in some sort of output array. So let's go ahead and make an output array here. I'm gonna do this in a separate line. Local, I think you do -a, out equals that. And this is also an array. So out equals that, it's an empty array. When we encounter anything, we can append it to the array. So we can push this onto the array. That's the syntax in Bash for pushing. So now this output array will get built up every time we encounter a new directory, and every time we encounter a dot dot, we will back up off of it. So there's a cool little trick to pull out the last item of an array and unset it. We unset the variable name at -1. Yes, this works. You put the whole thing in a string. This might look kind of gnarly if you've never seen this before. We unset it, and this will fail if the array is empty, but we don't care if it fails, the array is empty. We just throw out the error messages here. Simple as that. So all this says is delete the last thing in the array. So either it was set to something and we just delete the last thing in the array and the array moves back one, or it was an empty array and at the end of this, it's still an empty array. And that's it. Like, that's it. So now we just have to rebuild the path. We have an array of all the path parts. We need to rebuild a string that represents a path. So we'll make a local thing for the string. We're going to change the IFS. So we're going to do this in a subshell. IFS equals slash, and then we put a semicolon there. And then we just take our output and use this star notation. Because remember, the star is for stringifying an array. So we do this, we echo S. We need to put back the slash at the beginning. And we're done. We've normalized a path. So let's go ahead and run this. There we go. That looks right, doesn't it? Let's uncomment this. Let's uncomment this. And there we go. This looks pretty good. Like I said, this is for educational purposes. I may have missed something here, okay? This is a pretty good path normalization thing, but if you're a cybersecurity expert, you might find a way to break this. So, have fun with it. So let's go ahead and copy that into our web server. So we'll grab our normalized path function here. Copy, go over to that file. Let's jump to the top and let's paste it here. Beautiful. Awesome. So where do we call that? I think we did the URL decode. Yep. So we will just put this down here as normalize path. That's it. So let's do an example here. There we go. Did we chop off? Yeah, we chopped off this one. Okay, cool. Just want to make sure I'm consistent with my commenting. This is sort of what we expect, So let's just make sure I'm being very consistent with my comments. Yeah, and after we normalize the path, then that's gone. So if that works correctly, we should be able to run our Bash web server. We should go over here, and there should be that giant printf to try and get Etsy password. This should fail. That worked. Why did that work? Oh, yep. Because our normalized path function returned a slash at the beginning of it, which is correct that it makes it absolute. This returns a slash at the beginning of it because it normalized it to where we were. We just need to go ahead and chop that off again. Probably could leave it on. We could probably just move this whole thing to the bottom, but we're gonna be safe here. We're just gonna repeat a little bit of work and do this. Chop off that slash if it exists. What's going on? There we go. Let's go over here. 404 not found. Beautiful, beautiful. That is what we want. That is what we want. Look, see, it's trying to read out of our current directory. That is great. That is awesome. Is there anything else about this that could break? Maybe. Look at this. This tries to find an empty file. That's because we're trying to list nothing. Now this is okay. This will just fail and we'll just get a nice little 404 there. Pretty sure it's a 404. Let's double check. Yeah, we should get a 404 there because the -f check for is a file is there. But this is definitely something to keep in mind. We'll come back to this later. So in this example, what is the right course of action, right? If we try to list nothing, what should happen there? Or even beyond that, what should happen if we try to list, let's say, make dir my dir, and then let's touch my dir a dot text, something like that. What should happen in this case? So we have a directory called my dir. We run that. We go over here and we try to curl my dir. What's the correct course of action here? Because we get a 404 because we're doing a file check on it, but it's not a file, it's a directory. So what should happen in this case? Because what I want to have happen is if it's a directory, I want to get a directory listing, right? That's what I think makes the most sense. So we have a file check here. That's great, but maybe we should have a directory check on it. So if it's a file, we'll do the nice little 200. Otherwise, we can do this. Elif, if it's a directory, again, we're stating the file multiple times, not great, but here we are. If it's a directory, then we can return the 200 OK, give it the content type text plain or even text HTML, because we're going to want a page that shows us what's going on. We could do something like this. List directory. Now, list directory will be a function that takes a path name, creates a nice little HTML list of all the files in the directory, and writes it back to the user. This function doesn't exist, so let's go ahead and write it. All right, so what do we need to do when we list a directory? There's a couple things we need to do. We need to get the directory name. That's $1. That's amazing. And then we need to output some HTML, right? Super simple. We can just put HTML here. We could say directory listing. Look at that. Super simple. Bash outputting HTML. That's not cursed, right? Now we could say echo, let's do a header of 2 over here. We can say directory colon the name of the directory, close that H2, change that to double quotes because we want that variable to expand there. That's amazing. What if the variable has greater than signs or less than signs? Is that going to break? Yes, it will, but we'll get to that. Echo, let's put a nice little horizontal rule here. Let's do open a new unordered list in HTML, and then we will loop the file so we can do for f in, that's the name of the directory, /star do, done, echo that. We'll come back, we'll finish that later. Then we just need to close the unordered list and put a final HR there. And there we go. That's some basic HTML. We're not doing body tags, style tags, head tags, anything like that. We're keeping it super simple. So what do we do here? We have the file name. That's great, but we're going to want the base name of the file. So the way we can do this in pure bash is we can say, starting from the left, go all the way, greedy match, anything you want to find until the final slash character. So anything up until the final slash character. Keep looking for slash characters from the left and delete anything up until that slash character. So everything we're left with is what comes to the right of the slash character or the base name of the file. Beautiful. So then we can check, well, we don't have to check anything. We can just print it. So we can print a list item, a href, our hyper reference, is equal to %s, close that, %s, and open this. Okay, so the reason I like printf here is because %s will just get replaced with whatever variable is, so I can just put it on its own line here, which is super easy to understand. So f is the name of the file, and f goes there, and that's it. This will work. This does everything we need. Doesn't check to make sure that the file names are valid. Let's worry about that later, okay? So we have a list directory function. That's pretty neat. So if we run this, what happens? What if we actually try to list, I don't know, a directory? Look at this. We get text HTML back, directory listing, my dir, and then we get all this. I forgot to get rid of the triple ... so I'm dumb. And that's amazing. What if we just don't give it a directory at all? Yeah, we get a 404 not found. Hey, you can't win them all. So it's trying to look for this empty string here. What we could do, this is a very, very simple solution, is if the path is empty. So if the path is empty, no, actually, no, let's use parameter expansion for this. handle empty path root path. So if the user requests just the root or the index path or whatever, we can do this. We can say path colon hyphen dot colon hyphen says if this is unset or it's set to the empty string, then default it to whatever this is. So in this case, we're just going to turn it into a period. That's all we're saying. If the user gives us nothing, we're going to turn it into just a period, which in this case is your current directory. So if we rerun this, go over here, run this, we should get this directory. How beautiful is that? Okay, let's go ahead and get rid of those triple dots because those are annoying me. Where did I put those? There they are. Let's go ahead and get rid of those. Run this, go over here. And hey, that looks awesome. We can do the real test for this. This is amazing. This is amazing. I did kind of click on some of these files, so that's why they're purple, but this is amazing. It just works. Like, this just works. So we should be able to go to mydir, right? Can't connect to server. That part's not great, but hey, at least mydir worked. What happens? Can we refresh it? Oh, it works if we refresh it. So maybe it sometimes works, maybe it sometimes doesn't work. We'll get to that because yes, that actually is the case here. So now that we're in mydir, well, it's not that easy to go back, is it? Can we make it easy to go back? Wouldn't it be nice if there was a dot here? I think it would be nice. Get ready for how easy that is to implement. Let's go ahead and edit the bash server. We list the files in the directory here. Let's go ahead and do that. Just add dot to the list of things we're looping over. That's it. So at the top of the list, our dot will be there. So pull up Safari, refresh. There's our dot. Go ahead and click that. There we are. We have a little directory listing. How beautiful is that? So what are some things that are going to break here? This is what I love to talk about on this channel. Well, how about this? Make dir, empty dir. Let's go ahead and run our server. We have an empty directory now. Let's go ahead and refresh this. There's our empty directory. Let's click into it. It thinks there's a file here named star. There is no file named star. Why did that happen? Because of globbing. Globbing is what caused this problem. That's because if you try to glob something, like if you try to do like foo star, there is a file with foo in it. That's awesome. But what if we did baz star? There is no file, so it just left it as that literal star character. That's the problem with this. You need a shell option to ignore this. So let's go ahead and pull up that source code. In our list directory, we're going to change a shell option. Technically, this will change it for the whole process, but it doesn't really matter. We don't really care if that's the case. shopt-s, shellopt-s for set. So we're going to enable it. We're going to do two things here. Null glob and dot glob. Dot glob will show hidden files. So if there are files that start with dot, we are going to see them now. And null glob will cause it to not hide any files from us. In fact, let's be so sure of this that we can set glob ignore equal to this. We won't inherit it from the user. We will manually say that, no, we're not changing anything based on globs. Now that I say that out loud, I'd actually like the user to be able to customize that. We're going to take that out. So null glob and dot glob here. The beautiful thing about this is now we will get rid of that star character. So if we go over here, we rerun it, we pop open the web browser, refresh this, that star character is gone away. It's no longer there. Thank you, null glob. How amazing is this? This is wild. We have a web server in bash. Isn't this crazy? So can we break it? Yeah, of course. Let's fix some things about this now. Let's be good about what we're doing. So in our list directory thing, there are two things that are happening here that are bad. We are taking data that's on the file system and we are injecting it into raw HTML and into raw HTML tags. So what do we need to do here? Well, right here, we need to HTML encode this one. We need to go down here. We need to HTML encode this one. And then this thing in here, we need to URL encode it. Remember how we did URL decode down here? We need to do the opposite of that process. We need to URL encode that. So let's go ahead and find a suitable URL encode function. We have that. Thank you, Bash Bible. Super nice. So we're just going to steal this code, and by steal I mean use, because it's all released. I believe it's open source. I have to double check the licensing on this, but we're going to go ahead and use this code. So we have URL decode. Now we will have URL encode. And oh, I use tabs, they use spaces, so we do have a little bit of a mismatch here. I am going to modify the style just to match mine, just so it flows better in my editor. Some people are going to hate this. Yeah, that's tough. Get over it. So here we do this. We do command substitution, and the command we're going to run is URL. No, not here. Very close. right here. The first one, we're going to URL encode $F, close that. There we go. So what's left is HTML encoding. Now I've looked in the Bash Bible. I don't see anything about, what's going on here? I don't know what happened there. I didn't see anything in the Bash Bible about HTML encoding, so we're going to have to write our own HTML encode function. Luckily, encoding HTML is super easy, and I've written it before because my whole website, if you've never seen my website, is written in Bash. So you can curl my website on your terminal. Oh, really? It's just slightly too big to look good? Look how beautiful that looks. Oh, that website's awesome. This is going to come up later, so remember this website. The reason I bring this up is because I actually wrote a tool in Bash to do this and then HTML encode it. So I've written this logic before. It's not that scary. Let's go ahead and write our HTML encode function here. And this will make a string that we take as argument 1 safe to display in HTML. How do we do this? Well, we have to modify the string slightly. We have to say s equals s, and then we're going to replace / for replace every single occurrence of an ampersand with amp semicolon. That's what we have to do. And then we have to do it for a couple more characters. So real quick here, we're going to start with the ampersand first. That way we don't double escape anything. And we have to do this. This is very important. We have to escape the ampersand because ampersand has a special meaning in Bash. This will get replaced with whatever was matched over here. So in this specific example, it won't matter, but it'll matter in future examples. So now we just repeat this for a couple different characters that we can have. So we can have less than characters, we can have greater than characters, we can have double quotes, and we can have single quotes. Single quotes not a huge deal, but we should just be good. So this becomes less than, this becomes greater than, this becomes quote, and this becomes apos for apostrophe. That didn't work. There we go. That's how we HTML encode a string, so we make it safe to display in HTML. Now that we have that, we can do this. HTML encode that, close it up, and that's beautiful. Then we do the same thing down here. HTML encode that, close it up, and we're good to go. So if we rerun this, and then we go to our website, it should be safely escaped for us. So it works. Nothing's different though because we didn't put any unsafe characters in here, but what we can do is we can look at this in our terminal to make sure everything makes sense. So we go over here, we can recurl this, and then we can see foo %20bar.txt, whereas up here we had the space. So we are correctly URL encoding it. We don't have to worry about any of this. If we were to, let's say, touch some dangerous files here, let's touch less than, touch greater than. I think I actually swapped the symbols around. Just ignore that. Touch. This has quotes. There we go. Let's go ahead and rerun that. Come over here, run our curl, and we can see that the foo %20bar, %3c, %3e. So this has quotes in it. It's correctly escaped everything. This has apos quotes in it. So we're correctly displaying this in a way where we're not going to break anything. That's beautiful. Super simple. If we pull the web browser up, you can see we got the greater than, the less than. Yeah, they're swapped, but hey, the point is they work, and we are correctly escaping this in a way that can be safe to view as a directory listing. So what do we have left to do? We have a couple things left to do. Let's go back into our code. Okay, so we do this check here. If it's a file, then we serve the file. We use a built-in called bash, so we're gonna have to fix that. We are forking out to an external tool. If it's a directory, then we serve it like this. And if it's nothing, then it's not found. Wouldn't it be nice if this thing could serve HTML pages? So I think the goal of this should be, I wanna display my website. So, as I showed my website earlier, I could curl ysap.sh, and it's a little bit messed up from the terminal, but I can view my website over curl. I kind of want to be able to pull it up on my web browser and view it locally because the source code is local. Dev, ysap, website. I run make, they'll go ahead and make my website, make build. So it made my website, and now my website exists in an underbar site directory. So cd site, and here's my website. So we have an index.html page. We have all sorts of stuff here. I would like to be able to see this locally. So in order to do that, we have to make it serve these kind of files. So how do we do that? Well, we have to go over here and we have to do some sort of index checking. So how do we do this? We've got the path. We set the path to a dot if it doesn't exist, and then we try to find the path. Let's do something before that. Try to serve an index page. So the way we can do this is we can make a directory or an array of things to try. So here are the files that we want to try. The first thing we want to try is just the path itself. So if the user gives us like, foo.png, we want to try that first before we even try anything else. The next thing we want to try is path/index.html. The next thing we want to try is path/index.htm. So it'll go in this order. I'll try to serve the file directly. If it's not there, we'll try to get the HTML file. If it's not there, we'll try to get the HTML file. Otherwise, we'll fall back into this. So we do have to change our logic ever so slightly. The way we do this is we will check a, let's do this. Let's do underbar file and regular file. So we're going to loop over everything we need to try. So here we go. For try in to try. We're going to loop over every file we need to try. If the thing that we're trying exists as a file, then we save it. File equals try break fi. So now what this means is we're going to loop over this. So we're going to loop over the path. If that path exists as a file, then we're done. We don't need to look anymore. We store it in the variable file and we move on. If it exists as /index.html, then we store it, we move on. If it exists here, then we store it, move on. So when we get down here, all we need to check is if that variable is set. If that variable is set, then we know that it exists and we can try it. This is a static file that we need to serve. So a static file was found. That's what we're checking. So if the static file is found, then this is the logic we do in that case, the logic that we already had written. If the static file was not found, the next thing we want to check is if it is a directory. So we don't check the file name above, we check path. This was the variable we got from the user originally. If it's a directory, then we do the directory listing. Otherwise, we just give them the simple not found. Try a directory listing. Nothing was found. So now we should be able to serve a simple index page. So let's go ahead. We have mydir. Let's vim index.html. Hello, this is an index. Cool. So now if we run our bash web server, we go over here, we curl localhost 8080/mydir. We get mydir's directory. Oh, we just tried to cat the directory. That's so interesting. That's just a simple bug. Super simple. How we cat path here. We just need to change that to file. That's all we need to change there. So let's go over here. Hello, this is an index. We got it. We got the index page instead of having to specify it manually, which we can. We got the index page. How beautiful is that? So now we can actually serve index pages. So what do we have left? Because we've done a lot here. There's a little bit more that I would want. I want to be able to take data from the user. I want to be able to take some command line flags for this, right? So let's go ahead and let's do that. So we have the address, the port, and the dir is equal to dot. That's what we'll do, which is our current directory. So basically that means we're going to serve files out of our current directory unless anything else is specified. So let's go ahead and let's come up with a usage message. And let's save that till the end. We're iterating on this. So let's work quick here. Let's do local opt-in opt. We can do getops here. While getops, let's take a B, a P, and a D, and all of them will be optional. So we're going to match the arguments that accept takes. So we can say case opt in B. So that'll be the bind address. So we can say address equals optarg. Port equals optarg. And then D dir equals optarg. There we go. So now we take B, we take P, and we take D. That's super simple. So now we can do this. CD into dir, failed to move to dir. There we go. So what this means is with our web server, by default, it will serve out of our current directory, but we can give it our own port here. So we could say serve on port 1234, and now you can see it's serving on port 1234. We could give it a bind address of 127.0.0.1 and have it serve on localhost, as you can see that. And then we can also give it a -D. -D takes the path of the website. So if you remember our tab over here, I have the website that I want to serve, and it's in this path. So we can go ahead and specify that over here as -D. So dev, ysap, website, underbar site, and it will CD into there. So it will serve files out of there. So now if I go over here and I curl, what is it, localhost 8080, I'll get an HTML page back. That's my website. That's pretty cool. If I curl index.txt, that's amazing. That's incredible. Is there a problem here? Well, there is a problem, but let's go ahead and let the browser tell us what the problem is. Let's go ahead and try and pull this up in the browser, and let's see what happens. Let's refresh this, and what happened? It's just showing us the HTML. It's not actually trying to render it. Do you know why that's happening? It's because we hard-coded the content type. So we have to add some logic here to mess with the content type. Where did I put it? Text plain, text HTML. So this, we need to actually try and get the MIME type. So we need to say like local MIME, MIME equals MIME type of the file that we are going to serve. And then we need to put the content type of %, and the argument that this takes is the MIME. So we need to come up with the right MIME type for the file, and we're going to base it off the extension of the file. So let's go ahead and write this function, because this function doesn't exist. We're not going to support everything, but we're going to try and support a small subset that could be kind of useful. Again, feel free to pull the source code down, modify it to your liking. So we just add a simple function here, MIME type, local f equals $1, that's the file name. And then we're going to have to get the extension from that file name so we can actually start doing something meaningful with it. So we have our f here. Let's go ahead and get the base name, bname equals f. Greedy, read from the left and delete everything up to the slash. This is effectively base name. Now we need to get the extension. So the ext equals base name #* dot. So this deletes everything up until the last dot. Now here's the thing. If there is no dot in the name, maybe you're just requesting a file that doesn't have an extension, it will be the same name as the string. So in that case, if the bname is equal to the extension, meaning that no translation was done, then we can set extension to nothing. There was no extension. So now we just do a simple case statement on this, and we can just write out the MIME type. Super duper simple. Case extension in, and like I said, this is not going to be exhaustive, but we can do all sorts of stuff here. So if it's HTML or HTML, we can do text HTML. You can go find these MIME types online. I just have a little list of some that I've written down here. Most of these I actually just have from memory, just because I've seen them so many times. Image, JPEG. Also, yeah, a lot of them are just super easy to understand, so that's the nice thing. PNG is a image. And finally, if we don't recognize what it is, application octet stream. This is the way of telling the browser, hey, I don't know what this is. This is just kind of raw data. So your browser will just, if it gets this header, your browser just initiates a download typically. This is how you can get something to just automatically initiate a download if the server request responds with this. So this should be our MIME type function. Did we call it properly? MIME type on the file. And then we just put the MIME type here. We should always get a MIME type back because of our default. Yeah, let's go ahead and run this again. Let's go ahead and go to our web browser and let's refresh. Moment of truth. That looks like my website. That definitely looks like my website. Being hosted from Bash. How incredible is that? Do you notice anything wrong here? You might not notice anything wrong here, and that's okay, because I don't expect you to know my website as well as I do. I'm going to show you something. Here's my website pulled up properly. Notice how the terminal is typing in itself? That is JavaScript that does this. When we go back to localhost, nothing's happening there. Do you know why nothing's happening there? If we inspect element and we pull up the console, look at this. It's no good here. failed to load resource, could not connect to server, couldn't load some of these files. And if we refresh it, it couldn't load them again. So some loaded, some didn't load it. Do you know why that's happening? And this is the really unfortunate part, but we're going to talk about this. Let's pull back up the terminal. Let's see what's happening here. This built-in of accept is not ideal. It is a one-shot server. So it creates the socket, it binds the socket, it calls listen on it, and then it gives you one client. Once that client is gathered, it closes the socket for you. This is meant for one-shot processing. So this whole thing blocks. We have to process the entire request and write back to the date or write back to the client before we listen for the next request. That is not ideal. We can speed this up and we can get pretty good, but we can't solve it completely. But let's speed it up right now. The really easy way to do this is to go back into what, the early 90s, or late 90s, early 2000s? I don't know. Back when all web servers were forking. We're going to do the forking method. Let's fork this in the background. So we'll process the request in the background, and then we'll immediately be able to accept the next connection. We still have to create the socket again, so there still is a race condition here, but it will be a lot faster. So let's do this, and let's see what happens. Because if I want to curl that, like I did over here, what happens? Well, we curl it, but the connection's hanging. We go over here. It looks like it's working, but why is the connection hanging? Didn't we close the socket manually? Why would that socket still be running? We actually closed the file descriptor manually here, right? So why is that happening? Well, when we added this ampersand, we put it in the background. That means that there was a fork that happened. So this file descriptor that was created during the accept call is now duplicated. It exists in the parent process and it exists in the child process. This is a problem. It's not a problem that a file descriptor is duplicated. It's a problem that we need to close it everywhere in order for the client to know. So we close it explicitly in the child, but we don't ever close it in the parent. So actually, here's a fun little thing we can do. We can move this line, we can copy it here. We can immediately close the file descriptor in the parent because we've passed it to the child. The nice thing is once the child process is done, it will close that automatically because it will die. So we can actually remove this from the child and just close the file descriptor immediately in the parent. So let's go ahead and let's rerun this. Go over here, curl it, and it looks good. Now it's returned back to me. So yeah, that's a cool little trick. It's because the file descriptor was duplicated. So we open it in the parent, we send it to a child process, immediately close in the parent, and let the child process handle it. The child process doesn't need to close it. The child process just exit. It's just done processing the request. So the file descriptor will close automatically. So that's the beauty of that. All right, so at the beginning of the video, I said I would come back to this. So I want to come back to this now and kind of show what's going on here. So in this example that I pulled up earlier, the bash web server, a purely bash web server, no socat, no netcat, etc. Yes, this is exactly what it says it is, and it is doing it the same way that we are doing it, okay? We are using accept.c, they are using the loadable plugin. They go ahead and they add things like sessions and stuff. So this is amazing, very full-fledged, it does WebSockets and still, which is wild. So this is doing what we're doing. Like I said, I'm not the first to do this, but this is doing what we're doing. Huge shout out to this. They even had their own patches to it. So if you're using the accept built in, you're using their patch, which is super cool. It's super awesome. Unfortunately, it still fails from the same problem that we have, which is, you know, it does a one-shot accept. So you can see down here, they do something very similar. They have a lot more code than we have, of course. They have a lot more features than we have. But there is, oh man, let's see if I can find it. Yep, they accept, they write out to a new file that they spawned a whole process. They do a lot more work than we do, but long story short, they do the same thing we have to do where you close the file descriptor and you go back to the beginning of the loop. This thing loops forever until it becomes time to accept a new connection. So again, this does what we've done so far. Obviously our code's different, but this does a very similar thing, but it still has that accept problem. It still has the problem where accept only does one connection and then closes the entire socket and you have to reopen the connection. So, you know, hopefully there's some way we can make that better. If we look at the terminal, we were able to load the ANSI.css. I don't think we loaded that one before. So we're loading more, but we're still losing the race here. So this is unfortunate. This is just because of the nature of the built-in to bash, which unfortunately is just how it is, right? So this is where the story ends. Bash's built-in is not able to handle opening the socket and remaining open and letting the user call accept on it multiple times. So Until someone pulls down the bash source code and writes some C code to make their own loadable plugin, it's not going to work the way we want it. So we would need someone crazy enough to do that. All right, so let's pull down the bash source code and let's write our own accept and listen logic for sockets. Let's actually go down and do this work. What do you say? I think this will be fun. Okay, so I tried cloning from all three of these and the first two failed and the third one hanged? I don't know, whatever. So we're gonna just clone the mirror off of GitHub because this will probably just work. So let's go ahead and copy this, pop over to the terminal. Let's do a nice little git clone here. And there we go. Now we're gonna pull down the bash source code. Okay, we got the bash source code, let's cd into bash. And to run this is super easy. We just run configure. This will go through, figure out everything about our system and figure out what kind of build system makes sense for this. So then after we run this, we can run make, which will compile bash. So I'll let this run, this will take a bit. All right, let's run make and okay, 24 seconds, not bad. So that's fully compiled now. If you ls it, all the stuff is here. So if we wanted to, we could just run bash. And there you go. We're just running the newly installed, or not installed, compiled version of bash. We don't want to do that. Let's go to the examples, loadables directory, and here are our loadables. So we could run make on any one of these and just create it. So I think we can do make accept, and there we go. Now we have accept here. We can't run this. It's not an executable file. It is a shared object, so we should just be able to enable it. So the enable built in, this will pull accept that's in bash. We can do -f and give it a file. So the file we're going to give it is the accept thing that we just compiled in our current directory. So this is the file, and this is the name of the built-in. We run this, and now we've loaded it that way. So what does that mean? Well, let's talk about accept.c. We have accept.c. Let's go down here and let's show how it works. Super duper simple. We validate the port from the user. We make sure it looks good. We check to see if they gave us a name for the variable. Otherwise, we use this name for the variable. Simple, simple, simple. We create a socket. We set the address of the socket. We set some options on it. We bind the socket. If you've never seen code to make a socket in C, this is very simple, very straightforward. Create the socket, you bind, then you listen. This is where it'll actually start listening on that port for new requests. And this is the important part down here. This is where we call accept on the socket. So notice what happens after we call accept. This is how you accept one client. One client. Normally you would call accept in a loop if you were to make like a web server or something. We accept one client and then we instantly close the listening socket. So this accept built-in is great for a one-shot, for I'm making a server for one thing to talk to me and one thing only because I'm going to close it immediately. So what we would need is our own built-in. I'm going to make two just because it'll be easier, but we could have our own built-in that will call socket listen. So we can just listen on a socket and return the file descriptor of that, but not close it. And then we'll have a second built-in called socket accept, which will take that file descriptor, accept a single client on it, give it back to us, and not close it because we can just keep calling accept in a loop. So let's go ahead and do that. Let's cp accept.c into two files, socket accept.c, and this one will be socket listen.c. Before we go any further, I'm just going to go in the make file because I've looked at this code before and I know that each file has its own section here. So we're going to find accept, which is right here, and we're going to add two new ones above it, socket accept. And we'll change this to socket listen. This way we'll just be able to give them as target names and they'll get compiled. So we should be able to run make socket accept, nice, make socket listen, and they'll both compile. We haven't modified any code, so I'm not going to do anything fun here, but let's go ahead and modify some code. Socket listen. So this is the first thing we would run. This would set up the server to listen for us. We're not going to change any of the arguments. We're just going to leave them as is. It's not pretty, but here we are. Let's go down here and let's figure out where it actually calls accept. Here is where it calls accept. And that is what we don't want. So let's just get rid of it. As simple as that. We call listen. If there's an optional timeout thing, we set the timeout stuff on it, and then we just return success. Simple enough. Cool. Let's go to socket accept. This is where we accept the request on a socket that already exists. So we will have to take the socket as some sort of argument. Luckily, that's easy because they've already done the hard work for us. They take the port as an argument. So they check if legal number, iPort, they call it iPort. Let's change iPort. They have iPort and UPort for unsigned port and signed port. Let's change iPort to, I don't know, how about iSoc? That's the socket FD. So where they accept that, we're going to check here, and then they turn into UPort. We don't need UPort. We don't need ours to be unsigned. It's a file descriptor. It's signed. This might be some ugly code, but let's start deleting code. So this calls accept once. Let's get rid of the part where we close it if it fails. Let's get rid of the part if we close it here. So we never actually close it, and then we just return it. That was really fast. I may have missed something. That code may not be valid. The usage messages are definitely not going to be valid. But let's go ahead and make them. That looked good. Socket accept. That looked good. So now we should be able to enable -f socket accept. We'll call it socket accept. That failed. Oh, I have to change the names. Huh. So let's open up socket accept.c, and I think they just call it accept. Yeah, the built-in name. Here we go. This is what I get for not reading documentation and just making code changes. There we go. Hey, that looks good. So now let's go and do socket listen. Change the name to socket listen. Call this socket listen struct. There we go. Okay. So now we got them both compiled. They're both running. So we should be able to do socket listen. So this will set up a listening socket for us. The V will be FD and the port will be 8080. And it just returns immediately. Cool. So that didn't work. I might have deleted some code that I actually need. I'm gonna pull up accept.c. Okay, I was going about this all wrong. Socket listen. We need to bind the variable. We listen. We don't actually store that variable here. We need to do that here. There we go. So this will bind the variable to whatever the user gave us to the serve sock, and the serve sock is this call to socket. So this is the file descriptor of the socket. Okay, so this should work now. Make socket listen, enable socket listen. Let's call socket listen VFD 8082. There we go. Now we have a file descriptor 5. That's where it's listening on. So we should be able to call accept on this now. So socket accept -v would be client. Then we can say the file descriptor here. So FD here. Socket operation on non-socket. Oh, we were so close. Oh, yeah. I just missed a variable. Simple as that. We had serve sock, which was never actually set. So it's just a useless variable. So let's go ahead and get rid of serve sock and change it to, I think we called it iSoc. So I definitely do suck when it comes to writing code. All right, so we got that. Let's make it gmake socket accept. No, gmakes, I just make enable socket accept. Now we should be able to call socket accept on that FD, and the client will be the variable. So now we're going to call accept, so it'll hang until we make a request to it. So let's go ahead and make a request to it. Curl, I think we have it listening on 8082. This one's hanging, awesome. So the accept should work. So now if we look at the client, we should have a new file descriptor, 6. So we should be able to read from file descriptor 6, client, not FD, -r, into line, echo line. Hey, that works. There still should be more data to read. Hey, that works. So we just, yeah, once we call read here, then it will, yeah, okay, perfect. So we close this, that closes. So we can go right back into calling accept again if we wanted to. So without closing that, we could just create another one. How awesome is that? We never had to close the initial connection. That is beautiful. So let's go ahead, and now we're going to close these connections. Client, let's close the client. Let's close the server. So where does this leave us? Now we have 2 new loadables that we can call. We have socket accept and we have socket listen. So these are ridiculous, but here we are. Let's go ahead and load these. We're going to go back into our bash web server. we're going to vim the bash web server. And this is the one that works, but it kind of breaks. So we're going to CP this over to bash web server.safe, just so we don't lose the code. I want to check all this in and make it available to all you. Let's call the bash web server here, and let's use our built-in ones. So how are we going to do this? We're going to hard code some paths. Get ready for this. Dev, bash, examples, loadables, socket, accept. Or, there we go. And then we have socket listen. Oh, don't forget to give them their names. Socket accept, socket listen. There we go. So what do we do now? We have socket accept and socket listen. So we can move these out into two separate calls. So this one will be, let's do this. So the FD and the IP will be available here. We won't get the IP here. The IP will be in the accept call because this will be socket listen. So it won't take a -r. And then this will return the FD that we need to care about. So now this will, instead of setting FD here, we will set this as client, set this as client, set this as client, and we're not going to listen on a port. We are going to listen on the FD above. There's a lot that happened here, but if this all works, then we should have a bash web server that can listen on a socket and accept multiple times on that socket without having to close it because of our C program. So let's go ahead and run this new bash web server. That seems pretty good. Seems like it's working. Can we curl localhost? Seems like it's working, right? That seems pretty awesome. Let's go ahead and give it the -d dev ysap website site. That looks right. If we do index.txt, that looks right. So the moment of truth is, can we go to the web browser and run this? And it works. It works. Ladies and gentlemen, it works. Take a look at the terminal. As you can see, it got all of the files necessary. The reason it was able to do this is because we added our own built-ins. We are able to listen on a socket and then call accept multiple times on that socket. So because of that, every file that I needed to load is here. So we can load the website perfectly over localhost. So we should be able to go to episodes, should be able to go to resources, contact. This is just my website, so nothing fancy going on here. This is incredible. Oh, and it loads so fast. When I'm clicking around, you can just see like, oh, they just flood in. It's beautiful. It works. It's amazing. It loads images. It loads static files. This is so incredible. So that's our bash web server using 0 external tools, right? Well, hold on. Wait, there's still one thing we have to talk about. What about that call to cat? This is technically an external tool, right? Is there a built-in cat? There is a built-in cat. Here's the problem. My system didn't come with it for some reason. I don't know why it didn't come with it because it's there. If we ls dev bash examples loadables, it's there. But for some reason it didn't come there by default. So we could compile it, but my version of bash did come with T. So T is very similar to cat. Now T will write to files as arguments instead of reading from files as arguments. That's the only difference. But it's a good program. It reads from standard in and writes to standard out. And we need to do that with binary data. Bash can't handle binary data directly. So we're going to have to use this built in. So let's go back in here and let's make this thing not fork and exec any external tools at all by swapping this out for T. Now, we don't want to give this file as an argument. We want to read in from file and write to FD. That's how we accomplish it. And then we can do a nice little enable T or exit here. So now we rerun this bash web server and there we go. Go to the website, refresh it, and we're good to go. This is a bash web server running with 0 external fork and exec calls. There are no external tools being used, just loadable plugins that were loaded at runtime. So we needed T or cat to be able to read binary data because bash does not have a built-in way of handling binary data. It's pretty bad at handling binary data. and we needed to be able to listen and accept separately. Technically speaking, we're able to run this just by doing the one-shot accept in a loop, and by putting it in a child process, we're good to go. But that's kind of lame, so we had to use our own version of the bash built-ins. So I will go ahead, I will make the source code available. If you want it, I will link it in the description below, so you can go find it there. If you've made it this far, thank you so much for watching. Go ahead, hit that like, subscribe button, do all that fun stuff. I do have a Patreon. I'm going to shout it out. Just hit like and subscribe. Honestly, thank you for sticking around this far. Hopefully this was fun. Again, I'm going to link the source code because I had a ton of fun writing this. And I'll put the bash built-in source code up there. It's kind of just lifted from the bash source code. So that code is GPL3. So my changes and modifications will be GPL3 as well. The web server code I wrote will be licensed under the MIT license, which is what I license most of my code under. But yeah, the built-ins are GPL3. So I'm not going to change that. That's how that works. So yeah, thank you so much for tuning in, everyone. That is a bash web server in pure bash. And yeah, hope you all had fun.